Let's now discuss a more involved scenario where we have two people working on two parts of our solution. In this case, a second programmer is tasked to develop a second GUI interface for the same project. This is an advanced GUI with more involved features and a bigger touch panel. So this will live as a separate project inside our solution. For the sake of our demonstration, we are not going to be using squash mergers, but regular merges. More on that in a second. So the lead programmer, in this case Alvaro, is going to create a second project where a second programmer, John, is going to do his development. Using the solution we made in video number 3, we are going to go to Construct and create a new project. We are going to name that project Advanced GUI. Now we're going to commit that change. And we're going to push it. So now Alvaro informs John that he can start working on the advanced GUI. So to do that, he's going to share the GitHub repo address. Now I'm going to move to a second computer to demonstrate this. So now we are in John's computer. We know because the taskbar is on the left side. So John is going to go to GitHub, paste the link that Alvaro just shared with him, which is our feature branch Git flow solution. It's going to copy the clone link to the clipboard. He's going to open Visual Studio Code. Another way that we know that we are on John's computer is that he's using a light theme for VS Code. And now John is going to go to source control and he's going to click where it says clone repository. He's being asked to provide the URL, which by the way is almost the same. It only has the .git at the end. VS Code is going to ask us for a place to save it. We select the folder construct uses, which is documents, restaurant construct, solutions, and we're going to put it there. So now VS Code loads the code from GitHub, puts it on our computer, and it's asks us if we want to open the repository. We're going to say yes. We trust the folder. And as we can see, we have the exact same setup that Alvaro has. If we go to history by going to source control and clicking the grid graph button, we can see that the history is exactly the same. And we also can see who has created all of these commits. So now the first thing that John needs to do is to start his own branch. So he's going to go to the corner, create new branch, and he's going to call it Advanced GUI Development. So now what John needs to do is to open the solution. And a quick way to do that is to go to Explorer, right click anywhere over here, and click on Reveal in File Explorer. That shows you exactly where the folder is located in Explorer. We can double click, and now we can double click on the Construct solution. Construct opens the project. And now John can start working. He's going to go to the Advanced GUI project and add a couple of pages. Page 1 with a button. And now he's going to save. He's going to go to VS Code. He's going to stage the changes. And he's going to commit. Now he's going to go back to construct, create another page, and put a button list. He's going to save, go to VS Code, stage the changes, and add a commit. This is it for John's work. We're going to go now to Alvaro's computer. So while John is working on those changes, on the other computer, Alvaro is working on his own stuff. He's going to go to his local repo. He knows he needs to develop something new. Go to the bottom left corner to start the creation of a new branch. Create a new branch called development. And now he's going to go to construct and create a new page for with a D-pad and save. Clearly, the things that John is working on had not appeared because we haven't done any kind of synchronization that will alert our project that something happened. So now Alvaro is going to go to VS Code, stage the changes, and commit them. Now we are back to John's computer. He is done with his changes, so now he is ready to push them to the remote repo and tell Alvaro. So now when we go to GitHub, we can see that GitHub is telling us that a new branch was added. Here's the main branch, and here's the branch that was just added. So now we are back on Alvaro's computer, and we already see in the history that there has been a change in origin, and that is the creation of the advanced GUI development. Now, we're not going to do anything with it right now. We're just going to publish our changes to GitHub of what we just did. So we're going to publish the changes. We go to GitHub, and now we can see the two new branches that have been pushed, one by John and one by Alvaro. Now, when we go back to John's computer, we can see that John can tell that a new branch exists in origin and that it was pushed by Alvaro. Also notice that none of these changes had affected main. Main has stayed back, and the only branches that were created was the advanced GUI development and the development branch. Now what VS Code has been doing is automatically fetching changes from the remote repo. It has not actually applied any of those changes to our local repo. We know that because this branch called development is not in the list of local branches shown over here. We only see remote branches. We can also see that on Alvaro's computer. When we look at VS Code, there's the development branch, but locally, there's not an advanced branch. Pay special attention on how Git graph is showing the branch information and where it is located. A remote branch that is not in our local repo is shown as the remote repo name, in this case origin, then forward slash, and then the branch name. That's John's branch, Advanced GUI Development. While a branch that is on our local repo is shown as branch name first, development, the branch that we've been working on, pipe, and then the name of the remote repo. Now Alvaro has two tasks to accomplish. Since he is the lead programmer, he needs to merge his changes to the main branch, and he needs to merge John's changes to the main branch. The first task is simple. Alvaro just needs to go to the main branch. He can do so by either right-clicking in the main branch on Git Graph and clicking Checkout Branch, or also by going to the bottom left, selecting Branches, and selecting the main branch. Now you can see that the main branch is bold with a circle. Now we're just going to do a normal merge, not a squash merge, so that the whole history is preserved. We can do that also by clicking on these three dots, click branch, click merge, select the branch that we want to merge from, in this case development. And now we can see that main goes all the way up and is on par with development. We can check quickly that if we go to construct, nothing has changed. The page 4 is still there, and the advanced GUI, there's still nothing of John's changes reflected in it. Now Alvaro needs to pull advanced GUI from the remote origin and merge it. We know that advanced GUI is not in our local repo, just on the remote repo, because if we go to branches once again, the only local branches are development and main. It is showing that advanced GUI development is still in the cloud in GitHub. So we could pull the branch from the remote repo and merge it at the same time. We would go to branch, merge, and select the branch in the remote repo. But Alvaro needs to make sure that John changes are okay. So all that he wants to do right now is to check out John's branch, which is automatically going to pull it from the remote repo. So to do that, again, we can click on the bottom left, click the remote branch that we want to check out. And now you can see that the name changes to show the name of the branch first and the name of the repo second, telling us that now this branch it's in our local repo. Now, if Alvaro goes now to construct, he doesn't see John's changes. Again, this is a byproduct of construct. He needs to close the solution, open it again, and now he can see John's changes, the two pages that he created. He also cannot see the page that he created, and that makes sense because the only thing that we see is the exact same copy of the repo that John has when he pushed. So now Alvaro can go and check John's additions. There's page 1. There's page 2. So now Alvaro is happy with John's work, and now he's going to merge John's work into main. So Alvaro is going to head to VS Code. So the first thing that he needs to do is go to main. See how the circle is now in main. If we want to check, we can go to construct. It's going to tell us that certain things have been deleted. To make sure that he has taken all of the changes, it's better to close the solution and open it again. Nothing on their advance. And here's the fourth page that Alvaro created. So now Alvaro can go back to VS Code and proceed with the merge by selecting branch, merge, and clicking on John's branch. Notice how Git graph shows the merging point and also how Git automatically created a commit called merge branch advanced GUI development. This was truly a merge since it combined the changes from Alvaro with the changes from John. Git did it automatically because it detected that none of the changes were going to create a conflict. And now notice how Git graph is also showing the path of both branches, showing the complete history between the two of them. So now let's check construct and see if the changes actually take. Again, we're better off if we close the solution and open it again. And now we can see John's changes as well as Alvaro's changes, both of them being merged together. So now Alvaro is happy with the changes and he can go ahead and delete both branches. He's going to delete first his. He can also delete the branch in the remote. It's no longer necessary. And same with John's branch. All that is left is the history of the changes and not what branch they came from. So now we're happy with the way things look, and we can finally synchronize all changes into the remote repo. So now when we go to GitHub, we can see that there's no longer the other two branch, and we can see all of the commits. And just to be thorough, let's see what John sees. When we go back to John's computer, we see the whole history, including the merge that just happened. We see that John's local repo is still pointing to his branch. And now what John is going to do is move into the main branch. Notice that the main branch showing here is his local main branch. He needs to select the new branch that exists in the remote repo. And now he can go ahead and remove his local branch. Notice how in his end, the two branches that no longer exist in the remote repo is still showing up, and they're still going to show up even if we do a fetch. We can go ahead and delete them just to remove them from the history. And now John's history matches Alvaro's history. This is the ideal way to work when dealing with merges. Two groups of people are working on completely different folders. Because they're working on completely different folders, there are not going to be any collisions, and then Git can easily figure out what needs to merge where. We haven't yet tackled what happens when actually two people make a change in the same file. We are going to talk about that in the next video.